Hello everyone. In this video I'm going to be covering how to calculate the percentage error in the time period of a pendulum. So I've got this example question here. As you can see, you've carried out an experiment to investigate the effect of the length of a pendulum on the time period of oscillation. Theory says that the pendulum should follow the given rule here, where T is the time in seconds, L is the length in meters, G is gravity. Calculate the expected percentage error in the time period if the length is 1.5% too high. So, starting off from this equation, we can rearrange it to get this. T equals 2 pi, you'll need your calculator for this one, 2 pi half G for gravity, and a half. Now, incorporating what we know, so we know that G, gravity, we know that is 9.81. So, again, T equals 2 pi 9.81. And a half. That's a half to the power of a half. L. And then to the power of a negative half. These are to the power as well, in case I didn't say. L, 1, so that's going to be our length. So finding our length here, we can find our length by rearranging this equation. So L1 equals 1 plus 0.015 squared. If you're wondering how I got these numbers, if you just use your calculator to rearrange this equation, we get this. So L1 equals 1 plus 0.015 and 2. Then after that, we get T equals 2 by incorporating what we now know. So pi, 2 pi 9.81 to the half. That's a bit of a weird looking bracket. To the half, 1 minus 0.015, close bracket, to the power of 1 negative half by our length. And then going on, we simplify it down further. Time equals, do time 1, equals 1 plus 0.015. If you're wondering how I'm getting these numbers, just use your scientific calculator, and you can see that I'm simplifying the equation down as much as I can over to the 1/2. Then we get T time. So time 1 equals 1 plus 0.015, closing our bracket, to the half by T, and that finally gives us our answer, which is 1 plus 0.0075 T, which means that, now this might look like a bit confusing, but that's our sure answer right here. This means that the percentage error in the time period is 0.75%, and that is, the pendulum is 0.75% too large. And naturally, if the length was too short, then it'd be too small. So that here is our answer. Again, if you lost me part of the way through the video, feel free to pause or replay the video to see what it is you missed. And again, if you're confused about any of the steps, I'm using a scientific calculator to simplify down the equation. I hope this was helpful, and thank you for watching, and if you haven't already, please consider liking and subscribing. Thank you.